everyone. Hi everyone, I'm back with another practice example. In this one, it says use the superposition theorem to find V naught in figure 2. Okay, so let's solve for this one. When you hear superposition theorem, you have to see how many sources you have. We have one here, and then one here. Okay, and then with the current sources, this is how it works. So superposition theorem says, first of all, divide, do this step by step, remove all sources except one, analyze the circuit, and then find the solution for that one. And then you keep doing this, keep doing it till you considered all the sources. And then the final answer is summation of all of the previous solutions. So solutions, okay? And now when we say remove all sources except one, okay, what does it mean? So now let's remove all sources. What does this mean? Okay, removing sources. Okay, so if it's a voltage source, then it would mean short circuited. So you would short circuit all the voltage sources except one to keep one of them active. Or if it's a current source, you remove a current source by open circuiting it. Open circuiting means this I becomes 0, so that's how you remove it, the effect. So now let's go back to our circuit. In this circuit, we have two voltage sources. I'm gonna call this V1. This is this is source 2. Let's call them sources so it's more general. S1, I actually like to call this one S2 because it's similar, and then S3. Okay, so we're going to start with S1. So when we want to consider S1, we have to remove S2 and S3. So now we have to draw the circuit again by removing S2 and S3. Okay, so the equivalent circuit when we only have S1 is going to be 20 volt, and this is going to be 3 ohm. Then we have 2 ohm, 4 ohm, 5 ohm. And then what happened here? S2, I open circuited it, so it's as if it's not there. And then here, instead of S3, and then S2, here, instead of this voltage, I short circuited. This is instead of S2. I confused myself by naming it. Stay with me, guys, it's just names. Okay, S3, okay? Easy. So we have two sources, and this is minus plus V naught. We need to find what is the voltage across the 4 volt. So this is kind of like an equivalent circuit model, equivalent resistance, because in order to find 20 volt, to find how much the 4 volt is, the 4 ohm voltage is, we have to find its current, right? So you can do this by voltage division. So right now that S2 is short circuited, 4 ohm and 5 ohm are in parallel. So this circuit becomes, it's gonna take some time, but you'll see. 20 volt, 3 ohm, 2 ohm, and then 4 ohm, and then here we have 4 ohm in parallel with 5 ohm, which is going to be 4 multiplied by 5 over 4 plus 5. So it's going to be 20 over 9. .2. So that's like 2.22. Okay, then that is in series with the 4 ohm. So then step 2, we do another circuit model. Two ohm, and then here we have the 4 ohm plus 2.22 ohm, which is 6.22 ohm. And then one more step, we do 20 volt and then 3 ohm. Here we have 2 ohm in parallel with 6.20 ohm. Oops. Which is going to be, I'm gonna clear this, 2 multiplied by 6.22 over 2 plus 6.22, which is going to be 12.44 over 8.22. 1 point something. What? No. 12 point. Okay. So that's about 1 point, let's say 1.5, for example, 1.4, 1.5 ohm, for example. Okay, almost. Then, so now we can find the current that gets out. Now we have to go step by step back. This I is going to be, I is equal to 20 over 3 plus 1.5, 20 over 4.5, which is going to be 4.44, 4.44 amp. Okay, so now we have 4.44 amp as a total. 4.44 amp. Now since this is about 3 times of this guy, so we need to find how much I1 is, and this is I2. Then we say I1 is 2 over 2 plus 6.22 multiplied by I. 2 over 8.22 multiplied by 4.44 amp. .08, so this is 1.08 amp, and then so here we have 1.08 amp going in, so the voltage of 4 ohm is going to be 4 multiplied by 0. Amp, which is going to be 4.32 volt. Okay, but remember, this is this way. This is V1. Just remember, when we add this, it's important because the current direction is that way, and this is the original one that is asking in the question. So now we continue with S2 the same way. So number S2, we remove S1 and S3. Again, S3 was the current source, so this time to remove S1 we short circuited. So this one at the beginning of our circuit, then we have our 3 ohm, 4 ohm, and then 2 ohm, 4 ohm again, and this is our 5 ohm. We have about 30 volt here. This is very similar to the previous one. We just have to, this is again our S3, this is our S1. So we need to do the same thing here. Again, we draw it. So we have 30 volt, 5 ohm, 4 ohm, 4 ohm, and then here we have 2 ohm in parallel with 3 ohm, which is 2 multiplied by 3 over 2 plus 3, which is going to be 1.2 ohm. Then again, what we have is 30 volt, 5 ohm, 4 ohm, and then the 4 ohm and the 1.2 are in series. So this is going to be 4 plus 1.2 ohm, which is going to be 5.2 ohm. Then again, one more step, 30 volt, 5 ohm, and then here we have 4 ohm in parallel with 5.2, 4 multiplied by 5.2 over 4 plus 5.2, which is going to be 20.8 over 9.2. $2.3, let's say. So this is 2.3 ohm. So now we do the same thing. We find the current I of 30 volt. I of 30 volt is exactly equal to 30 over 5 plus 2.3 ohm, which is going to be 30 over 7.3. .1. So we have 4.1 ohm here, 4.1 amp. So we have 4.1 amp going here, and then now it has to get divided between the 4 and the 5.2. So here we have I1, I2. In order to find the 4 ohm current, we need to calculate I2, which is going to be 4 over this resistance over the summation of the 2 multiplied by 4.1. So it's going to be 16.4 over 9.2. 1.78. Let's call it let's say 1.78. amp. So here we have 1.78 amp going this way, and then this is 4.1 amp, right? And then about 2.4 of it, or 2.3 of it, goes this way. 2.3 amp goes this way. So now V naught, or V of 4 ohm from S, V naught of 4 ohm from S2 is about plus minus this way 4 multiplied by 1.78 amp, which is going to be 6.12 volt, if I'm not mistaken. 328, yes. But remember, like when the current goes this way, the plus is here, minus is here. The voltage always decreases as when we move in the direction of the current. Our voltage was plus here, minus here, because we had 1.08 going this way. And this is because of the polarization of the voltage sources. The current always goes out of the voltage source, okay? So one way is to calculate the voltages, or we can just calculate the currents, you know, and then sum them up and then get the voltage. But in order not to get too far away, let's do step 3 here. So we have step 3, S3, remove S1 and S2. This one, again, this question is very simple, right? So we are, it's just like long. Okay, so now we are short-circuiting S1 because they're both voltage sources, 3 ohm, 4 ohm, and then we have 2 ohm, 4 ohm, and then we have 5 ohm here. And then instead of this guy is short circuit, and then instead of this guy is also short circuit. And you're like, oh, you forgot the S3. No, I haven't forgot it. It's right here. 5 amp comes here. Okay, so now we have, if we draw it another way, let's say we have 5 amp coming in, we have 4 here, then we have 2 here, 4 here, and then we have a 3 ohm here, we have a 5 ohm here, and then everything connects here, right? So I just rotated this. I know it doesn't look good. Okay, so we have some of the current, this 5 ohm going here, going here, going here. Then also the same thing at this node as well. Okay, so one way to try to do this is actually trying to solve this circuit, or we can try to find the equivalent voltage source of this guy. So we have 2 ohm, and then we have a voltage source plus minus 5 multiplied by 20 volt, and then 4 ohm, and then 4, 5. Okay, now we need to solve this guy, basically. Again, doesn't matter which one you try. I will try to solve this one just because it's different than a voltage source, to see how we can go about it. So we have 5 amp coming here, and we have 5 amp going here, and then we can call this I1, I2, I3, I4, I5. Okay, so we have 2 nodes. We have to write the 2 nodes. So we have 5 amp coming in. It's I1 plus I2 plus I3. Then 2 ohm and the 3 ohm are exactly the same voltage. So we have 3I1 is equal to 2I2. Okay, so here we can replace that one. And then in another one, we have 5 amp going out, plus I4, plus I5, and I3 is coming in, so they're equal. And then again, we have 4I4 is equal to 5I5, so we can say 5 plus I4 plus 4 out of 5 I4, sorry. I4 is equal to I3. The same thing here. 5 is equal to I1 plus I2, which is 1.5 of I1 plus I3. So I4.5 I1 plus I3 is 5. 4.5. And here we have I3 minus 9/5 of I4 is also 5. So 1, 2, 3. We need one more equation. How can I get that? We have I1 here, I2 coming here, and then I4 is here, I5 coming here. We have another node here. We can use that, or what else can we use? We can do a full circle inside here to relate I5 and I. So starting from here, 5I5 minus 3I1 plus 4I3 is 0. We are solving for 5 currents. That's one thing. Yeah, it's a little bit too hard this way. You know what? It was easier if I did loops. I think it was easier if I did loops. So let me just go back to loops. That's why loops are there. So we have I1, we have I2, we have I3. So that one was really hard, right? Now 3I1 plus 2I1 minus I2 is 0. These are different set of i's, and so yeah, this is the first loop. Second loop, 2I2 minus I1 plus 20 volt minus plus 4I2. This is the second loop. So this is the first, this is the second loop, plus 4i2 minus i3 is 0. The third loop, 4i3 minus i2 is plus i3 is 0. So here 5i1 is 2i2, and then here 9i3 is equal to 4i2. Okay, so now let's write everything in terms of i2 in this one. Yeah, this way it's much easier. And then i2 is exactly the 4 ohm, the current that goes through the 4 ohm. So here we have 2i2 minus 2 over 5i2 plus 20 plus 4i2 plus 4i2 minus i3, which is 4 out of 9i2 is 0. So 6 over 5i2 plus 20 plus 4i2 plus 4 multiplied by 5 over 9i2 is 0. So now we can do 45. 6 multiplied by 9 is 54, plus 4 multiplied by 45 plus 500 i2 minus 20. So 100 plus 0, 180 plus 54 i2 is minus 20 44 minus 900. I2 is equal to minus 900 over 334. Was it 900? I don't understand why it's getting that. Okay, 900 2.7, let's say. So minus 2.7 amp. So when it says minus 2.7 amp, let's see what we have. Now it's time to sum it up. Okay, so we had minus 2.7 amp. This I2 that we considered turned out to be minus. So we have a 2.7 amp in this direction then. That's what it's telling us. This minus says the direction of I2 that you considered is not right. You have to do 2.7 amp in this direction. Okay, so we had, from all sources, we had, let me go back here. We had 1.08 in this direction. This is our 4 ohm. This is our 4 ohm. We had S1 1.08 amp in this direction. Okay, then S2 from the other one, let's say this is actually, sorry guys, Since this is positive, this is negative, I'm going to calculate that I has to be in this direction to match the polarity of V naught, okay? So whatever current I had in this I direction, I'm going to consider positive, and the other one is negative. So S1, we calculated to be in this direction. So it's going to be minus 1.08 amp. S2, 1.78, I think. It was the right direction. Let's look at it. We had 1.78 in the other direction. So 1.78 amp. Then we had another 2.7 in the other direction from S3. S3, 2.7 amp. So now when we add I total is going to be minus 1.08 plus 1.78 plus 2.7, it's going to be 3.4 amp. And then V naught in the polarization that it showed us is going to be 4 multiplied by 0.4. It's going to be 13.6 volt in total. So very long one, and we learned a lot, but we finally got it. And then, is there any other question? No. That's why it was worth 20 points, guys. Okay, I hope you learned something. I definitely did.